In this video, we want to look at the CSEC Math January 2024 Paper 2, Question 5. So here in Question 5, we have the mass M in kilograms of 120 newborns at a hospital is recorded in the table below. So here we have the mass in kilograms. So this M here is the mass, and what this class interval is saying is that the mass here is greater than 2.6 kilograms and less than or equal to 3.5 kilograms. So this would be a lower class limit, and this would be an upper class limit. And of course, here we have the frequency F. So we have 7 newborns will be within this class interval, 18 newborns will be within this class interval, and so on. Now here for part A, part 1, we want to state the modal class. So that will be the class interval that has the highest frequency. So we look at the frequency column, the highest frequency is 30. Therefore, this class interval would be the modal class. The mass greater than 4.4 kilograms and less than or equal to 5.3 kilograms. So my modal class is 4.4 is less than the mass, which is less than or equal to 5.3 kilograms. Now moving on to part A, part 2, we have to complete the table below and calculate an estimate of the mean mass of the 120 newborns. Now the fact that they tell you that you have 120 newborns, it means if you add up the frequency, you should get 120. So sigma F should be 120. So I'm just going to do that on the calculator to make sure. So we have 7 plus 18 plus 30 plus 29 plus 28 plus 8 equal 120. So we see that the sum of all the frequencies would be 120, which is sigma F. And the reason we need sigma F is because we know the mean is sigma XF divided by sigma F. So that means we have to add up all the numbers in this XF column to get sigma XF and divide it by sigma F to get the mean. Now we can see this table have some stuff missing. We have stuff missing here in the sigma F column, and we have stuff missing here in the midpoint column. So let's fill out the midpoint first. Now what we could do is add the lower class limit to the upper class limit and divide by 2, and that will give us our midpoint. So you can just run a check and make sure that the midpoint is correct here. So we have 2.6 plus 3.5 press equal, and then divide by 2. And you can see that we got that 3.05. So we just continue with that, add the 5.3 to the 6.2, and divide by 2. So we'll have 5.3 plus 6.2, press equal, and then divide by 2. And we get 5.75. So we're going to have here 5.75. Then we'll add the 7.1 plus the 8, press equal, and then divide that by 2, divided by 2, and we get our midpoint, 7.55. So we have 7.55. And now remember, this column is X multiplied by F. Midpoint multiplied by frequency will give you the answers for this column. So to get what's missing here, we just have to multiply the midpoint of 5.75 by the frequency 29. So we're going to have 5.75 multiplied by 29, and we get 166.75. So I'm going to write 166.75. And then to get what's missing here, I'll multiply this midpoint, 7.55, by the frequency 8, so X by F, and that will give me the answer for here. So we have 7.55 multiplied by 8, and that will give you 60.4. So I'll have 60.4. So we have filled out the table, but remember we want to calculate the mean mass. So we need to get what is sigma XF, which means to add up all the numbers in this XF column. So I'm going to have sigma XF is equal to, and I'm going to add up 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4. Press equal and we get 651.3. So we have 651.3. So now the mean is equal to sigma xf divided by sigma f, which is 651.3 divided by 120. So we're going to type in on the calculator 651.3 divided by 120. Press equal and we get 5.4275. Now, seeing that the mass here was given to 1 decimal place and the midpoint, which is the midpoint of the mass, was given to 2 decimal place, I would approximate the mean mass to 2 decimal places. So we're going to have the mean is equal to, and if you look here, we have first decimal place, second decimal place is this 2. After the 2 is a 7, therefore this 2 goes up by 1, and I have 5.43 kilograms. So I'm going to write 5.43 kilograms as my mean. So now for part 3 of the question, we have one newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilograms. So looking back at the table that we filled out, we have our mass here. We've seen this 5.3 kilograms. We've seen it here and also here. So we have to read this class interval properly. M is the mass, and here we're saying that the mass is less than or equal to 5.3. So that's not greater than 5.3. Here, it's less than or equal to 5.3. But in this class interval, we have the mass is greater than 5.3. So from this class interval and down, we'll have the mass being greater than 5.3. So remember, the total number of newborns was 120, which was sigma f. Which means the number of elements in our sample space is 120, because that's the total number of newborns. So now all you have to do is calculate how many newborns has a mass greater than 5.3. And the frequency will give us the number of newborns. So from here, we starting from this class interval, go down. So that's 29 plus 28 plus 8. So the number of elements in a set, mass, greater than 5.3 kilograms, is going to be equal to 29 plus 28 plus 8, which is equal to, all right, 29 plus 28 plus 8, and that's 65. So here I'm going to have 65. So now the probability of a newborn having a mass greater than 5.3 kilograms is equal to the number of elements in a set, mass greater than 5.3, over the total number of newborns, which is the total number of elements in a sample space. So we're going to have 65 divided by 120, and that will be equal to, so we're going to type in 65 divided by 120. So we get 0.541 and so on. So to 3 significant figures, we stop at the 1. After the 1 is a 6, so you have 0.542. So that's 0.542. Now we could also break down this fraction into its lowest terms. And we can do that using the calculator as well. Alright, so we just use the fraction button and put 65 fraction button over 120, press equal, and you see the calculator breaks it down to its lowest terms, which is 13 over 24. So your answer could also be 13 over 24. So whether you want to write it as a decimal or a fraction, that's okay. So now for part B, part 1, we want to complete the cumulative frequency table shown below. So we have the mass here. Mass is less than or equal to 3.5. Mass is less than or equal to 4.4, and so on. And then we have the cumulative frequency. We have 3 of them filled out for us. We have to fill out the rest. Now I just brought up the table next to this table so that we can see the information that we need to fill out the cumulative frequency. Now notice your upper class limits is 3.5, 4.4, 5.3, 6.2, 7.1, and 8. Notice you are seeing the upper class limits here. And your first frequency is 7, therefore that's your first cumulative frequency. And then you're going to say 7 plus 18, and that will give you 25. And then 25 plus 30, and that will give you 55. So to continue, you have to put 55 plus 29. So 55 plus 29, that will give you 84. So I'm going to write 84 here. Then I'm going to have 84 plus 28. So 84 plus 28, and that's equal to 112. So 112. Then I'm going to have 112 plus 8. And that's obvious. 112 plus 8 is 120. Now notice your last cumulative frequency is the same as sigma f. It must always be like that. Sigma f and your last cumulative frequency must always be the same number. So moving on to question B, part 2, we have on the grid below, draw the cumulative frequency curve to show the information in the table in B, part 1. So remember, this is the table for B, part 1. So this is the information that we need to draw the cumulative frequency curve. So I'm just going to put the table here so that we can see the information that we need to draw the cumulative frequency curve. Now notice they have 1, 2, 3 points plotted for us. Notice this point here is plotted on 3.5. Therefore, we are using the upper class limits on the x-axis with the cumulative frequency on the y-axis. Now, notice you're not seeing the information for when the mass is 0, but to close off the cumulative frequency curve, they plotted 0 with 2.5. So we have this point here, which is this information here, 3.5 with 7. We have this point plotted here, which should be 4.4 with 25. Now, it's important to know what each little block represents on each axis so that you could figure out how to plot these points. So on the x-axis, we are going up by 1. So we have 10 blocks for every 1 unit. So we're going to have each block on the x-axis is equal to the unit, which is going up by 1 unit, over the number of blocks, which is 10. Because we have 10 of the smallest blocks between every unit here. And 1 divided by 10 is 0.1. Therefore, on the x-axis, each little block will be 0.1. So when we come here now, we are 3.5, 3.6, 3.7, 3.8, 3.9, 4, 4.1, 4.2, 4.3, 4.4. And that's why 4.4 is here. Now on the y-axis, we are going up by 10 units, and the number of blocks is 5. So each block on the y-axis is equal to the unit, which is 10, over the number of blocks, which is 5, and that will be 2. Therefore, every little block on the y-axis would be 2. So when you come here now, we are 20, 22, 24, and here's 26. So between 26 and 24 will be 25. And that's why this x here is in the middle of 24 and 26 for it to be 25. So now that we have established that, let's plot the rest of points. So now we have to plot 5.3 on the x-axis with 55 on the y-axis. So if you come down here, 4.5, here will be 5, and here will be 5.5. So from 5, 5.3 will be 5.1, 5.2, 5.3. And we're going all the way up to 55. So let's come back to this solid line here, go all the way up to 55. So 50 here, 52, 54, and 55 is in the middle. So I'll stop at the 54 here and let's go across to 5.3 now. So 5.1, 5.2, 5.3. And now 55 will be in the middle of this block here. So this was my point. So now we're plotting 6.2 on the x-axis with 84 on the y-axis. So here's 55. Here will be 6. See, 6.5. So here's 6. So 6.1, 6.2. So I'll stick to this line here with 6 and go all the way up to 84. So go all the way up to 80 here. So 82, 84, and now I'm going to come across to 6.2, right? So 6.1, 6.2. And now we're going to plot the 7.1 with the 112. So 7.1 on the x-axis. So here's 6.5. So here will be 7. So 7.1 will be right here. So let's stick to the line with 7 and go all the way up to 112. So going all the way up, 90, 100, 110. So 112 will be here, right here, 112. And I'm going across to 7.1, which is right here. And the last one will be to plot 8 on the x-axis with 120 on the y. So we have 8 here, see 7.5, so here's 8. And I go all the way up to its top, which is 120. So here we can see our S-shaped curve. We just have to connect these points using freehand, making a smooth curve, and that will be our cumulative frequency curve. All right, so that's the best I could do on the computer. All right, this will be our cumulative frequency curve. And now for the last question, which is B part 3, they want us to use the diagram to find an estimate for the median mass of the newborns. All right, so I just brought back the diagram so that we can use it to find the median. Now remember, we have 120 newborns. That means sigma F is 120, which implies that N, for formula for the median, would be 120. So our median, which is our second quartile, Q2, is equal to a half of the nth term. And we have 120 terms. So that's a half of 120. And a half of 120 is 60, so it's the 60th term. So we just have to come here on the cumulative frequency, find 60 on the cumulative frequency, draw a line across where it touches the curve, bring the line down, and that will be the median. So you can see we have a solid line where the 60 is, so we're just going to bring that across. It touches the curve right here, and we're going to bring that line down. And this would give us the median. Now remember, on the x-axis, each little block was 0.1, and this is just one little block away from 5.5, which means this is 5.4. So therefore, median will be 5.4 kilograms. And now just remember, when you're drawing these lines on your graph to estimate your answers, you want them to be dotted lines. So I'm just going to make it dotted. All right, so dotted lines to estimate answers off of your graph. And that will bring us to the end of this video. So look out for the next video on question 6.